AP Calculus, section 4.1, page 3. Today we're going to be talking about the extreme value theorem. Here's what it says. If a function is continuous on a closed interval from a to b, then that function f has an absolute maximum and an absolute minimum value, and they occur at a critical number or at an endpoint. So if we take a look at this, it sounds rather confusing, but really it's not when visually you look at this. So we've got continuous function on some closed interval from a to b. So some function in here on that interval. Maybe it looks something like this. That's a continuous function on that interval. And if we look at just this part, between A and B, right there, just that thicker part in here, is there an absolute maximum value? Sure there is. It's up here. It happens to occur at a critical number where we have a horizontal tangent. Is there an absolute minimum value? Sure there is, down here, and it happens to occur at an endpoint. So let's go through this again. If a function is continuous on a closed interval, then that function has an absolute maximum and an absolute minimum, and they occur at a critical number, there's one of them right there, or at an endpoint. Now you could have the absolute maxes and absolute mins, both of them be at a critical number or a relative extreme value, or you could have both of them be at endpoints. Doesn't make a difference. All right, let's take a look at this example. I want you to analytically find the absolute extrema of y equals x cubed minus 2x plus 4 for x between 0 and 4. So find the absolute extrema. That's asking you to find the y values. If I wanted x values, then I would say find the location of the absolute extrema. All right, to find these, first off, we're going to start by finding the critical numbers. Which means that we need to do a derivative. So y prime, that's going to give us 3x squared minus a 2. All right, if that factored, we would factor it. It does not factor, so we're going to jump right into looking for where f prime is equal to 0, where f prime does not exist, and where f prime is undefined. F prime, y prime, same thing. All right, where that derivative is equal to 0 is going to be where 3x squared minus 2 is equal to 0, where x squared is 2/3, x is plus or minus square root of 2/3. Because I'm old, I like to rationalize denominators. So x is plus or minus the square root of 6 all over 3. Those are some critical numbers. Okay, that was just for f prime equal to 0. All right, now f prime does not exist. Is there any place that this expression, this 3x squared minus 2, can be non-existent? No. Is it ever undefined to have a denominator equal to 0? No. None here. None here. So these two are our only critical numbers. Once you get those critical numbers, because we want the y values, we need to set up a t-chart of x and y values. And those absolute extrema are going to occur either at the endpoints, which are 0 and 4, so we're going to have to check those. Or those extreme values could occur at the critical numbers. square root 6 over 3, or negative square root 6 over 3. Alright, now we just take these four values and we'll plug them back into this y equation and see what happens from there. Alright, so let's take this 0. Plug this 0 in here. That's easy. That's 4. Plug the 4 in. That's 4 cubed. 64 minus 8 plus a 4. 68 minus 8, that's 60. Alright, square root 6 over 3 into here. Whew, without a calculator, that's brutal. Let's go here and let's do square root 6 over 3 cubed. Square root 6 over 3 cubed, and then minus 2 times the square root of 6 over 3. Plus a 4. And we have 2.911. Okay, now you could go back and plug in this negative square root 6 over 3 pretty easily, just going back and pulling this equation down and then changing that to a negative and putting a negative in here. However, look at the domain for this problem. The domain was between 0 and 4. Is this value between 0 and 4? Absolutely not. So we don't need to check it. That's not in the domain. All right, now once you have this t-chart completed, then we can go ahead and figure out where do we have our absolute extreme values. So looking at this, of these y values, the 60 is the largest, so we have an absolute maximum of 60 at x equals 4. The 60 is a y value. And looking at the y values again, this 2.911, that is a minimum value. So the absolute minimum is 2.911, and it occurs at x equals square root 6 all over 3. So analytically, find the absolute extrema. Here we go. Now verify your answer graphically. So we want to go ahead and graph this and look at this window between 0 and 4. So here's our equation. Y equals x cubed minus 2x plus 4. Window, I only need to see between 0 and 4. Personally, I like to go a little bit larger. I think I'm going to go between -1 and, say, 5. Y values. Well, it's here we know we're hitting 4, and we know we have to hit a 60 up here, so let's just make that a little bit bigger. How about, well, -10 looks good here, up to, say, 70 or so. Graph. And that's what we see. All right, let's go ahead and copy that graph onto paper. Doesn't have to be perfect, just reasonably close. Okay. All right, now let's just go through and identify a few important points. We had for, oh, I'm off a little bit here, that's okay, 2, 3, 1. And we knew we have a point right up here. 4, 60. We know that we have a point over here at 0, 4. And I'm supposed to have a minimum value right here. I think maybe this probably dips a little further this way. Oh no, it's supposed to happen at square root 6 over 3. Ooh, we better get a decimal for square root 6 over 3. What do you think? I got those turned around in my head for a moment there. Did you do the same? Let's see if I really did draw this accurate. So square root 6 divided by 3. Is 0.816. Ooh, I am off. I'm just off the other way. So it's supposed to be down here. I'll drop it down and bring it back up. There we go. Sorry about that. But I'm almost done with this page, and I am not going to redo it for that little bit in here. Let me just do this. There we go. And here's that minimum value right in here. That is square root 6 divided by 3, comma 2.911. There's your minimum. All right, thanks. Sorry about the error. Tune in to page 4 though.